Good day, this is Professor Kentop. This is section 3 of solution 2 for CSC 239, Scientific Computing Applications. It is important to understand that being able to automate processes and being able to work with command history is really important. But often using up arrow keys or the history command to repeat commands gets to be difficult. That's because if you look at the history and recall command by number, depending on what you're doing, if you're juggling tasks, the order of specific commands that you need to automate data processing is not cleanly in a list one after another after another. It's not a clean sequence. Because of the kinds of things you do. So it is important to be able to reference these, and it's helpful. But I would also say that while you're working with data, some things can change on your system. So the first thing that happens is that when you start working to develop solutions and to collect data, you have to be mindful of the disk space that's available on your system. Log files and data files can accrue very quickly. It's very important to understand that when you start automating processes or create custom solutions, custom applications that execute different applications in a different order, it's kind of a workflow management process to automate all of your experimental data collection and analysis. Sometimes bad things can happen. It's always good to capture log files in case something crashes. It's also good to capture log files in case somebody else is on your machine doing things they're not supposed to. So it's important to track both disk space and terminal activity. That's easy to do if you can capture the history and you can capture the disk space available at specific times or intervals. We can automate that process. In section 2, you may have noticed that using the cat command to edit some quick data in a data file was problematic. There was a mistake. I made a one-character mistake. I was too quick. I missed a line. I couldn't correct in that environment. I had to save the error as it is, remove the data or delete the data file, and then start all over again. It's not a very good method. CAT is good for quick things, and hackers love it because they don't need text editors or word processing documents to create code to hack things. And that's why they like it. But the simple truth is, when it comes to working efficiently in the line of work we're doing, text editor is ideal. And so in this section, we're going to review use of a text editor to automate the capture of logs that are important to track as we're working on data. So one of the useful commands for monitoring disk space is the df command with a -h or -h option. So if we type in df and then we want the human switch, it gives us megabytes instead of bits, and that's much easier to read. You can see which volumes have so much space left. So you can see how much is used and you can see how much is available, and that's particularly important when you have certain volumes that are used to store data. In this case, we have 71% utilization, so we need to keep an eye on this. As we're working with data, we don't want to run out of space because it can crash the system. It's easy to redirect this output to a file, but that's a manual process. And what we'd like to be able to do is to automate it. And then, in the course of automating the file, we'd also like to be able to have markers in that data file every time we take a snapshot. So we want to include a comment that says, or this begins or this ends, disk space capture, or this ends terminal activity capture, and then we want to put a date timestamp in it. To do that manually, as we've said before, so if you look at history, we want to capture the commands in history. We want to capture the disk space changes as we're working with data. So I'm going to use nano to create a shell script that's going to do both. And we're going to take a quick look here at what you should find in your Mod 2 solutions. So what you should have at this point are a series of lettered data files, A, B, and C. You should have 2 grade files with a final grade file. You should have 2 directories, data and programs. You should have a test file, and of course the directory out and directory out with your initials 1 and 2. That's what you should see at this point. What we're going to do though is again create these log files, and we're going to use a shell script. I'm going to use nano, and I'm going to create a file that's called grabactivity.sh. So that's what I'm going to invoke the nano command, grabactivity.sh, and it'll open up the text editing window for the .sh script, the shell script. First thing I have to do is include a line that's going to tell the terminal when it runs, hey, this is a shell script. So for everything that follows, execute each line one at a time as if Professor Kentop were sitting at the terminal prompt. So at this point, I'm also going to include a comment that explains what this shell script does, just because I want to self-document. So I'm going to say captures dated command activity and disk space remaining and remaining disk space. Okay, I'm gonna, yep, see, so making a mistake, but it's not the end of the world because I can just do this. Remaining disk space in terminal.log and disk space .log respectively. There we go. So the first thing I'm going to do is issue the df command with the -h option, and I'm going to append it every time. Whoops, didn't want that. I'm going to append it to the disk space log file. That's the first thing. But then I'm going to echo a line that says this ends disk space capture, and I'm going to say log. And I'm going to append that to the end of the disk space log. I'm also going to insert the date and append that as well to disk space log. Okay. Then just for my own sanity, I'm going to put a blank line in between there, and now we'll cat a file that contains the history of the terminal commands that are entered. And we're going to use a little bit of directory and pathing to make sure that works right. It's called the bash underscore history file, and it's in my home folder. So I'm going to cat the contents of cat the contents of tilde slash, that's my home folder, and then dot bash underscore history, and that's what I'm going to append to the terminal.log file. So I'm currently creating this shell script in the mod2 solution directory. If I try to execute this and just say .bash history, it's going to return an error and say, yeah, I can't find that. And we want it to take the contents of this log file, cat it to append it to terminal log. And then we're going to do the same thing where we echo this ends the terminal command history capture, and I'm going to append that to the terminal log. And I'm also going to do the same with date. So I have two different log files that are going to start building, and each time along the way I'm going to have breakpoints where I know the periodic captures were performed. I can take this script when it's done and use another program called cron to run this at regular intervals, so I don't even have to push a button. It's just going to run automatically, and that's going to help a lot. That way I can see changes over time and see if something crashes, what's going on. So I'm going to finish this terminal.log. So now I'm ready to save. I'm going to press the control key and X to exit, which is what I have down here. That's what these caret symbol with X means, control X. So I'm going to press control X. It asks if I want to save. I'm going to enter a capital Y for yes, and I'm going to keep the file name to write grabactivity.sh. Now if I list my directory contents, I should see grabactivity.sh. But there is one problem. You'll notice that it's not executable. So if I try to execute this, it's not going to run. And I'd like to test it to make sure it runs. So if first I'm going to enter grab activity.sh, and you're going to find that it doesn't know how to find the command. But wait a minute. It's sitting right here in the same directory. How come it can't find the command? Well, that's because I have to tell it to look in the current directory, /grab activity.sh. Now, as soon as I try to load this, another issue is going to come up. It's going to say permission denied. We've already talked about that. We'll use the change mode. I'm going to say that I don't want hackers to see what's going on here, or other outsiders, so I want to blank out these permissions. I want to add execute, And if somebody's in my group working this research with me, it's okay if they can read what's going on. But I don't want them to execute. So I'm going to issue the command change mod 7 and then 4 and then 0. 740. 740 grab activity.sh. It's going to return nothing, which means the command should have been successful. If I list it now, you see the color has changed because it's been activated for execution, which means I can run it now. When I run it, I should see two new files that appear, one called diskspace.log and the other one called terminal.log. Let's see what happens. /grab activity.sh. Nothing happens. But I do have a diskspace.log and I do have a terminal.log. What we want to do is cat the first one just to get a result, and then I want you to highlight, and then we'll get a screen capture, and this will end the first part of section 3. We're going to work with Python to automate something next using the text editor. So our first screen capture will be cat diskspace.log. And what we want to do is highlight this. You'll be able to see terminal.log and diskspace.log, and I'll be able to see the output. So no, this ends diskspace log capture. There we go. If I run it again, I should see two of these with a new date time stamp that's just 1 minute later. But I'll go ahead and capture this right now, and then we'll move on to the Python example. Quite often, it's much more useful to use Python to automate the execution of a series of utilities or apps. And creating Python is actually as simple as creating, it's even more simple than creating a shell script. There are some similar caveats. You do have to change the permissions in order to execute a Python program, and it's interpreted instead of compiled, so it runs real time. But we're going to use Nano to do that, and we'll create the program that you see on page 37 in the textbook, section 2.4.5, because we want to also talk about how to control a program that's running. We're going to create an infinite loop, and so infinite loop.py is what we're going to do, but instead of using cat, we're going to use nano. So I'm going to enter infinite loop.py, and just as we have the code at the top of page 37, I'm going to say, and ordinarily I would use descriptive variable names, but for the sake of efficiency and simplicity, we're just going to use single letter variables, even though that's a no-no. N equals 0, we're going to establish that a variable n is going to first contain the value 0, and then we're going to say while true, and then we're going to increment. While true, and then I'm going to come in down the next line. I need to hit or enter 4 spaces, and I want to be consistent each time when I indent with Python. That's one thing about Python that's important. I'm going to say n plus equal 1. That's shorthand for n is equal, while true, n is now going to be equal to 1. I'm going to assign the value 1 to n, and I'm going to loop it, plus it, to run it continuously. So plus equal 1, and then I'm going to print n. I have to 1, 2, 3, 4, print n. I'm going to go ahead and save this by pressing Control X. It's going to ask if I want to save what's in the buffer. I'm going to say yes. I'm going to save it to the file I chose, infiniteloop.py. And now, if I do this, you'll see I have infiniteloop.py. There's only one problem. I have the same issue with infiniteloop.py as I did with the shell script. I need to change. So I'm going to issue the same change mode command. Only this time it's going to be infiniteloop.py. If I list it now, I should see 2 executable, green, and I do. So now what I want to do is issue the Python. If I want to run this, I say Python, and then I give the file to put in there. And away we go. And what you see is a series of increasing numbers. And so what happens is that sometimes programs take off, and if we're not careful, especially if we're redirecting output for data collection to a file, the file gets bigger and bigger and bigger and bigger. And this becomes a problem. We have to be able to control the operation of a running program. That's why the keyboard control sequences in section 2.4.5 are so important. I want to call your attention to the most important ones. You're going to use Control S to halt the screen. Process is still running. You'll notice it's on 82.3225. I'm going to use Control Q to resume, but it's still running in the background, so you're going to see a much larger number instead of a slightly higher number. And basically, all that did was stop the values from streaming through the terminal. It did not stop the program. To halt the process temporarily, you want to press Control Z. Control Z is going to, it's like the pause button. It halts the process. It keeps the process from running in the background. But if I go ahead and press FG for foreground, it's going to resume the process again. And what do I do to stop this thing? Well, if I want to stop it, I've got 2 options. I can press Control C, and that's going to return an error message. It's going to say that there was a keyboard interrupt, close failed. It's going to cause a problem. A more graceful way of doing this is Control backslash. So I'm going to use Control backslash, and it quit the program and it dumped the memory. That's how we save the day. If we were redirecting to a data file to capture something and it was a runaway freight train, we could control backslash terminates the program cleanly without an error message. This concludes our second half of section 3. At this point, what you want to do is take a screenshot showing that you used control backslash to halt the running program. And that's what you need to do from here. This ends section 3 for solution 2.